The topic for today's training video is eucentric height in a TEM. In this video, we're going to explain what eucentric height means, why it's important in a TEM, and how to recognize and set eucentric height properly. So we'll start with the definition, and the definition of eucentric height is the height of a sample in an electron microscope where tilting the sample around the stage axis does not cause the image to move laterally. If you're more of a visual learner and that didn't mean much to you, don't worry about that. We're going to look at a visual of what that means in just a moment. But first, we'll start with a diagram of a TEM, and then we'll cut the microscope in half so that we can see the inner workings. We can see the electron beam shown in green and the sample holder, which is inserted from the side of the instrument. The electron beam has a complicated shape because it passes through a number of lenses and apertures. And in order to produce high-quality TEM images, we have to align all of the lenses and apertures. And that alignment is very sensitive and is specific to the position of the sample in the z-axis, that is to say, vertically. Because of this, we need to find a way to always position the sample at the same z-axis position in the TEM as accurately as possible. And this is where eucentric height comes in. Now, to make the diagram simpler moving forward, we're going to approximate the shape of the electron beam to be a cone shape, and we will focus only on the sample holder and the phosphor screen or the CCD camera. For our sample, we're going to use Purdue peat. Now in our simplified diagram, let's take a look at the outside of the TEM again. If you're working on a TEM where the sample holder and the stage are visible to you, you can actually see the stage rotate around its primary or its alpha axis. Most microscopes have a wobble function where you can tell the stage to constantly rotate back and forth around that alpha axis. Now if we slice our microscope in half again, you can see what happens to the sample at the same time. While the stage is rotating, the sample rotates as well. At this point, let's review that definition from earlier. Eucentric height is the height of a sample where tilting the sample around the stage axis doesn't cause the image to move laterally. So let's add the image of the sample, which is generated by the electron beam and is viewed on the phosphor screen or the CCD camera. Now, as the stage tilts back and forth again, you can see that the image of Purdue peat on the phosphor screen is not moving. And that is ideal behavior that we see when the sample is already at eucentric height. To demonstrate why this is happening, I'll put a red X on the stage. So the center of that red X indicates the axis that the stage rotates around. Right now, Purdue peat is right in the middle of that cross, so when the stage rotates, the center of Purdue peat's body is always centered relative to a single point in the electron beam. That's indicated by the black dashed line. You can see that the dashed line passes through Purdue peat's head, and his head is centered on the dashed line in the image on the phosphor screen. Now, it's very unlikely for your sample to be at eucentric height when you first load it into the microscope. What is much more likely is for your sample to be slightly too high or slightly too low. This could be caused by something as minor as variations in grid thickness or slight bends in the TEM grid from handling it with tweezers. And either way, when you first put your sample in, if it is lower than eucentric height like this, now when the stage rotates, you can see that Purdue peat is not staying centered along that black line anymore. When the stage rotates to the right, his elbow moves to be under that black line. And so his image on the phosphor screen moves to the right. When the stage rotates to the left, Purdue peat swings around to the other side so that his hammer is under the black line, and his image shifts to the left on the phosphor screen. There's no real magic here. It's just plain old geometry that happens to be hidden inside the TEM. So the opposite happens when your sample is too high. Now, when the stage rotates to the right, Purdue peat's image shifts to the left with his hammer in line with the black line, just because he is now above the tilt axis rather than below it. So when you're setting up eucentric height in a TEM, you can use the movement you see in the image to determine whether your sample is at eucentric height. If there is lateral movement during tilting, you're not at the right height. You don't need to memorize which rotation causes movement to shift right or left. Just start moving your sample up or down and see if the movement is getting worse or better. If that movement is becoming smaller, then that means you're headed in the right direction. And eventually, when you're exactly at the right eucentric height, you will see little to no movement on the phosphor screen or CCD camera during tilting. Hopefully this helps you understand what is happening inside the TEM during eucentric height setup, and to understand that the main reason we do this setup is to optimize our image quality by using the same Z position that is used for routine alignments. Most of the users in our center don't tilt their sample during analysis, but if you do, you can imagine how much easier tilting your feature of interest will be if the sample doesn't move while you're tilting. And that's another benefit to setting eucentric height in a TEM. So that marks the end of this training video, and as always, if you have any questions, feel free to ask the staff in the Purdue Electron Microscopy Center.